All right, this is Honors Algebra 2 Pre-Calc. We're doing 5.4 in Algebra 2, which is completing the square. And this time we're going to start addressing what happens when a, meaning the number in front of x squared, is not 1. So we saw this in the very first problem that I walked you through when I was showing you the steps, but let's go ahead and work through these. So we're going to complete the square. So again, the first step I'm going to take is to make that poor constant sit over in timeout by himself, right? So the negative 10 way over here gets completely ignored. Now I need to factor out a, and in this case, my a is finally not 1. What's going to happen when I divide these two terms by the negative 3 is I'm going to get an x squared plus a 4x, and then I leave an amount of space, and then my negative 10 is just sitting out here by itself, right? The constant's just awkwardly sitting by itself. When I do my triangle step, I'm going to take this number, I'm going to divide it by 2, so I'm going to get a positive 2, I'm going to circle it because it's important, and then I'm going to square it. So this is going to be a plus 4, but here's the trick. You didn't add 4. You added a 4 times a negative 3 because the 4 is in the parentheses and there's a negative 3 that would be in front of that. So you actually subtracted 12, right? That's what the negative 3 times the 4 is. So out here you're going to add 12. That's your balance, right? So what's going to end up happening is you're going to get a negative 3, which is this guy right here. Everything in the parentheses is going to factor into an x plus 2 quantity squared because you've created a perfect square trinomial. And outside you're going to get a plus 2 because that's what negative 10 and positive 12 give you. Okay, let's go to a P4. So same idea, you can ignore me and pause me if you want. So I'm going to start by separating this 7 out, right? Poor 7 sitting in timeout all the way over here. Now I'm going to factor out the coefficient of x squared. So I'm going to take out a 5 and be left with an x squared minus a 2x, leave an empty space, and then that plus 7 is still just chilling outside. When I do my triangle step, I'm going to divide this negative 2 by 2 and get a negative 1, which is important, so I circle it. I square it, and that's going to be a plus 1. But I didn't really add plus 1. I added 5 plus 1, right? That's a plus 5. So out here, I'm going to write minus 5. And what's going to happen is I'm going to get a 5, x minus 1, which I got from that circled number, quantity squared, plus a 2. Because again, what I've done in the parentheses is create a perfect square trinomial. All right, moving on. All right, so we're going to complete the square, but this is going to get a step harder, right? So again, we're going to ignore the constant. So 10x squared minus 50x, and then I leave the 14 all the way over here. Now, there is an interesting option here. If you wanted, you could try and take out a GCF, but it's not a great plan. There is a 2 in all of those, but it doesn't make your life better. So I would highly discourage you from doing it. And then I'm going to factor out my a. So my a is a 10, which means I get x squared minus 5x. So what makes this problem a step harder is that this 5 is not going to be nicely divisible by 2, right? When we do our triangle step, we know that we divide by 2. So I'm going to get a negative 5 halves, which is fine, but it's a fraction and people hate fractions. So when I square it, I'm going to get a plus 25 fourths, right? Well, what that means is I didn't add 25 fourths. I added 10 times 25 fourths, right? So the thing that I added, right, I currently added a 10 times 25 fourths. Or if you want to cancel a 2 out of that, right, you could cancel a 2 from that. So there's a couple options. You could either write this as a 250 over 4, which is fine. There's nothing wrong with that. Or you could actually cancel a 2 out of that, right? You could make it a $1.25 over 2. So either way, that's what I added. So out here, I'm going to subtract a 125 over 2, which is good times. So now I'm going to get that this is a 10 times x minus 5 halves quantity squared. And then I'm going to treat this 14, right? I'm going to treat this 14 as a positive 28 halves, right? That's what 14 would be. So essentially, I've got a positive 28 halves minus a negative 125 halves, right? So seems like I'm going to do essentially a 125 minus 28 and then put a negative in front, right? And if I did that, I should get something in the neighborhood of a 97. So I'm going to get a negative, so technically this, but I'm going to get a negative 97. So I get negative 97 halves, and that's my answer. Yay, fractions. Cool. So here's your P5. Same idea. You're going to get a nice fraction. So 2x squared minus 6x, awkwardly put the 5 in timeout. Take out a, which is going to be 2x squared minus 3x, leave a space, right? So now when I do my triangle step, I'm going to divide by 2 and get a negative 3 halves, which means that when I square it, I'm going to get a plus 9 fourths. But I didn't really add 9 fourths. I added 2 times 9 fourths, which would be 9 halves, right? So I added 9 halves, Out here, I'm going to subtract 9 halves, and this one's much nicer than the one that I gave you a second ago in the example. I'm going to get x minus 3 halves, quantity squared. And then out here, I'm going to have a 10 halves, right? This is actually 10 halves minus 9 halves, because 5 would be 10 halves, so I'm going to get plus 1 half, and that's not awful. It was definitely not as bad as the one I gave you a second ago. So that's it, and then in our next video, we're going to go ahead and talk about vertex form and graphing.